So we'll be okay, guys. Good evening to all of you. So today we are going to learn about we'll learn about hydrodynamics. As in the last class, I taught you what is hydro. What is hydrodynamic? Hydrodynamics means liquids in motion. Okay, liquids in motion. Correct. Till now we have studied liquids at rest, but now we will study about liquids in motion. And I told in the last class that hydro means water, a liquid, and dynamics means in motion. Okay, so last class we have seen, I gave an example that where do you see the liquids in motion? You see in a tap when you on the tap you get the water. That is also one that example. Rivers, streams, rivulets. Okay, these are all the various examples of what? Canals, various examples of liquids in motion. Okay, and so we will learn about the physics part of that. We will study some terms like steady flow, flow line, streamline, flow tube, laminar tube, turbulent flow, streamline flow, about that. Okay, so to start with, I let's say example, I am in a winter season. Okay, I will give two example. One is winter and in rainy. Tell me, in which season you find water very strong or very fast moving, in winter or rainy?
Rainy.
Because the amount of water is more. Okay, so you will see speed in the, if you compare the just a generic speed, nobody knows physics, you can tell that yes, in winter it flows smoothly, but in rainy it moves like this. You can't say that. When you say this one, it says that if you compare each, it's like a flow line, a line, it is slowly moving, it is like parallel, very uniform, with spacing, very uniform, with constant speed, kind of. But if you see here, there is no, you cannot say any relation, it is very fast, it is turbulent rather than violent. Yes or no? Yes or no? So if I compare
Yes,
it
sir.
with a tube, if I compare with a tube, let's say this is a tube. So these lines, if I consider, this is called a flow line. What it's called? A flow line. It's a particle moving. A particle, water particle will keep moving like this in a line. It's called a flow line. Understood? It's an individual parting. It's a path basically.
Yes.
Path. Path. This is a path. This is a path. You can have multiple paths. Obviously, there'll be infinite path. Infinite path. Infinite path. Infinite path. I'm just giving a generic what, it's a pipe, like a pipe kind of thing. Clear? Understood? So the path of the particle moving from A to B is called a flow line. Is it clear to all of you? Is it
Yes,
clear?
sir.
Yes, sir.
So for example,
Yes, sir.
Yes, sir.
for example, let's say this path is not straight. This looks straight, but actually it need not be straight. Why? Your pipes can, you can have pipe wherein pipes are like this. Yes or no? Can't we have pipes like this? Hmm? Or can't we have pipe like this? We can have, right? Rivers also
Yes,
like this.
sir.
So there is not necessary that the path will be always straight. Okay. So if the path is not straight, if the pipe is bent, then how will, let's for example, the flow line will be something like this. Yes or no?
Yes, sir.
Yes, sir.
So now tell me, at this point, if I draw a tangent, how the tangent will be? Yes or no? You agree with me or not?
Yes, sir.
Yes, sir.
At this point, the tangent will be like this. At this point, the tangent will be like this. At this point, something like this. Yes or no? You agree with me, all of you?
Yes,
Yes,
sir.
sir.
Tangent
Yes,
to the
sir.
tangent to the flow line. Tangent to the flow line is called streamline. Understood? Understood?
Yes, sir.
see here, the flow line is like this, but the tangent is like this because it's a curve. But if it is a straight line, now tell me, for a straight line, what is the tangent? The tangent will be same only, no? Yes or no?
Yes, sir.
Yes or no? Others?
Yes, sir.
For a straight line, the tangent is same only, no? The flow line and the streamline are same. These flow where the flow line are straight, parallel to each other, it's called steady flow. Did you guys understand? Did you guys
Yes,
understand?
sir.
The path where the flow lines are parallel to each other and moving with the same velocity. That means if I take a point, here, a point here, a point here, a point here, this point is equal to this point, this point is equal to this point, so each one is moving with a constant velocity. Did you guys understand?
Yes, sir.
Yes, sir.
Velocity,
Yes, sir.
constant pressure. Pressure means, now let's say you are going and watering the plants in a garden. So what do? You always try to press the end, right? The opening end where the water comes out. You always try to press, and you try to sprinkle it more. Yes or no?
Yes, sir.
So what is that? You are trying to give more pressure in there, but only for that part only the pressure is more, not for other parts. But here, so that there the pressure is variable. Only at the end, here the, let's say Rishabh is standing. Rishabh is holding the pipe here. Rishabh is pressing this part of the pipe so that the water goes far. So only for this part the pressure is high. But what about the other part? It might not be that much. It might not be that much. The pressure is only high this part. See, pressure cannot be same. You can't say that it's same. I don't know. But obviously the pressure here is more than this. Yes or no? Yes or no?
Yes.
Yes, sir.
So the flow,
Yes, sir.
steady flow, is a measurable property which says that the pressure and the velocity of the fluid at any given point of time is constant. Is constant. If this travels 5 meter per second, this also travel 5 meter per second. This also travel 5 meter per second. This also travel 5 meter per second. Did you understand, guys? Is it clear to all of you?
Yes, sir.
Yes, sir.
First clear? Very important, guys. Very, very important concept. See, for a curve is not a steady flow. Why? Because this is not constant. Why? Tell me. Why? Because when we talk about steady flow, we talk about velocity and pressure to be constant. Is the velocity same here and here? No. The velocity, here the direction is this side. Here the direction is this side. The direction is continuously changing. Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
You know, we already studied in the previous chapter that for a circle or any curve, the tangent tells the direction. Yes or no?
Yes, sir.
So when the tangent is
Yes, sir.
changing, the direction is changing, how the velocity can be constant? Understood? All of you? So steady
Yes,
flow
sir.
Yes,
is
sir.
always straight, which has same pressure, and the velocity is same at any given point of time. Is it clear?
Yes, sir.
Now we will come to flow tube. What is flow tube? Flow tube is nothing but an imaginary bundle of flow. See, let's say I am getting flow lines are like this. So this is a bundle, just a tube, just an imaginary tube. If you're keeping this, if you're taking this 1, 2, 3, 4, 5, 6, 7 flow lines, the one which encloses the 7 flow lines is called a tube, flow tube. Is it clear to all of you?
Yes, sir.
Yes, sir.
Swaroop clear? Tarang clear?
Yes, sir.
Very, very important. Flow tube is an imaginary, it's an imaginary bundle of flow. with the imaginary wall. I am saying just maybe some wall is there. It's a imaginary. Understood?
Yes, sir.
Steady flow cannot cross the wall, but turbulent can cross. We'll come to that. What is laminar? What is streamline? What is turbulent? We'll understand. Okay. Next, we'll come to what is a streamline and what is a turbulent. What is a streamline? What is streamline? What is streamline? Have you seen the shape of a fish? Have you seen a shape
Yes,
of
sir.
an aeroplane? Have you seen the shape of a bird?
Yes, sir.
Yes, sir.
Not exactly, something like this. So what do you see? What do you
Sir, it
see?
can be
What
bolded.
do you see common? This structure, yes or no? Structure,
Curve, sir.
not curve, pointed, like a pointed. The front part is pointed.
Aerodynamic.
Yes. Why? Why? Have you seen a bird like this? Have you seen any aeroplane like this? No. Why? Because
No.
it has to cut the air. You have to cut the air. The earlier the ambassador car used to be something like this, but nowadays your cars which are mainly for sport purpose, they are almost like this. Yes or no? Yes or no?
Yes, sir.
Can you
Yes, sir.
can you use these cars for sport? No. Why? Because they don't have a proper streamline structure. So better the streamline is, more better, faster it can go with less consumption of fuel. If you go 100 kilometer per hour in this, and if you go 100 kilometer per hour in this will be able to go faster. You'll be able to consume more fuel, consume
Sir,
less
your
fuel.
voice is breaking, sir.
Your voice is not coming me properly.
Sir,
Let
your
me
voice is breaking.
1 minute. Let me go to the other. Just hold on. Hold on. Hold on. What about now?
It's clear now, sir.
Yes, it's clear.
Yeah. So what I was trying to say, that both the jeeps, both the car with this structure and this structure, if travel 100 kilometer per hour, this car will have less fuel consumption. Why? Because it will be easily able to cut the air and able to go because of this nice structure. So the streamlined structure is very, very important for all this. Understood? So similarly, water also, if you drop a glass of water, you will see that water will go like this, but when it flows, it will always be like this. It will be like this. Just try to drop water and see, and try to see from this side. You will see the water will flow like this, and the front part of the water will always be a streamline. Did you guys understand? Did you guys understand?
Yes.
Yes, sir.
So I'll give the definition. You can write. It is a steady flow. It's a steady flow in which adjacent layers of fluid move smoothly over each other. मतलब आराम से, very slowly, smoothly it goes. Smoothly it goes. When you try to put, just try to take a slope and put water, you will see smoothly it goes down. Don't give any force, just drop आराम से, आराम से. And it is also say laminar flow. laminar flow. Okay, it's streamlined flow is a type of steady flow only. Obviously, the pressure and the velocity will be constant. Understood? Understood.
Yes, sir.
And the flow lines will always be parallel to each other. They will never intersect. You cannot have like this. You will always have the flow lines parallel. So they will never ever intersect each other. Is it clear?
Yes.
Yes, sir.
So flow lines are clear, streamlined. Now we will go to turbulent. What is turbulent? The word says it is violent or random. Okay, not uniform. Rainy season. It can have anything. They will intersect. The flow lines can go anywhere. Random. Write down. The flow, it is a flow. It is a flow at a very high rate. It is a flow at a very high rate. So that there is no steady flow. There is no steady flow. And the flow pattern changes continuously. The flow pattern, here it is like this. Maybe here it is like this. Here it is like this. The flow pattern changes continuously with time. Example, river during flood or over water flow in rainy season. Is it clear?
Yes.
What about the velocity? Is the velocity constant? Is the velocity constant? Harsh? Is the velocity constant? Harsh?
No, sir.
Velocity is not constant. Okay. Pressure also not constant. Nothing is constant. Okay. And there is no orderliness. Randomness. कुछ भी वो इधर भागता है उधर भागता है. It's like a class is going on and you tell the students, hey, go and play. They will just randomly go. But whenever they go for a prayer, they go in an orderly fashion. So whenever we talk about order, uniformness, okay, we talk about streamline. Whenever you talk about randomness, violent, or disorder, we talk about turbulent. Is it clear to all of you? Is it clear?
Yes, sir.
Yes,
All of
sir.
you clear? This might come in question. Okay. So we'll go to the next topic. We'll go to the next topic, that is critical velocity. What is critical velocity? Write down the definition. The flow of a liquid. So what tells whether the flow is streamlined or the flow is turbulent? What decides? What decides? The flow? Yes or no? If the flow rate is very high, then what it will be? It will be turbulent. Yes or no? And if the flow rate is steady or smooth, then it is streamlined. Yes or no? Yes or no? And when I
Yes,
say
sir.
flow,
Yes, sir.
when I say flow, what do I hint about? I hint about the velocity. The velocity of the particles or the water particles. If the velocity is high, that means there is something, some barrier. Like below this, we talk about it's a streamline. Above this, we talk about the as turbulent. Yes or no? Are yes or no? When you talk about something
Yes,
is
sir.
turbulent,
Yes, sir.
something is smooth. I talk about something, some barrier. This barrier, this minimum is called critical velocity. Critical velocity. That means you can write down the velocity, write down the velocity beyond which above, मतलब ये अगर मान लो सिंपल, ये आपका एक वेलोसिटी है, ठीक है, बिलो दिस इट्स अ स्ट्रीमलाइन फ्लो, above this is a turbulent. So the velocity beyond which the flow, the streamline flow becomes turbulent is called critical velocity. It is a minimum velocity. If you go above this, then it becomes turbulent. Is it clear?
Yes, sir.
Yes, sir.
Is it clear? Very, very important, guys.
Yes, sir.
So beyond the velocity beyond which the flow, the streamline flow becomes turbulent is called critical velocity. No confusion. So there is some expression. We will understand the expression. Hello, can you hear me?
Yes, sir.
So the expression is Osborne Reynolds in 1842-1922 designed the velocity, the expression for critical velocity. What he gave, Vc is equal to RH into eta divided by rho into d. This is critical velocity. RH is called Reynolds number. Reynolds number. Basically, it's a number, no unit, just a number. 2, 3, 4, 5, 10. Number only, a number. It's not in the value of, not in the. It's a natural number. Natural number. Okay, and no unit, obviously, no unit, no dimension for this. Eta. It is called the coefficient of viscosity. Coefficient of viscosity. D is the density. Sorry, it is a diameter of the tube. So if you are flowing the water, what is the diameter? Diameter of the tube, and rho is the density of the fluid. Is it clear?
Yes, sir.
Yes.
Critical velocity is nothing but Reynolds number RH into eta divided by rho into d. So what do you see? Can we conclude from this that critical velocity is inversely proportional to the diameter, and critical velocity is inversely proportional to the rho? That means if the density of the fluid is very, very high, like what? Can you tell me what? Honey is more dense than water. Yes or no? Yes or
Yes,
no?
sir.
Yes,
The
sir.
honey is more densile. Then if you want to flow honey and water, which will go faster? Water. Yes or no? Yes or
Water.
no? The velocity of the water will be faster than honey. So understood? If the rho is more, if the density is more, then the velocity is less. Similarly, you want to flow water in a thinner tube and a bigger tube. Which will go faster? Thinner tube. Why? In a bigger tube, it will prone to turbulent. There are chances that become turbulent. But here you might have smooth flow. So it also depends on the diameter of the tube. If the tube is more fatter, then there is chance that velocity may change. Why? Because there is more chances of turbulence. But in a thinner tube, the chance of turbulence is very, very less. Is it clear?
Yes, sir.
Yes, sir.
Then if I want to write what is Reynolds number, then Reynolds just take this one that side, it will be Vc into rho into d divided by eta. Understood? And what is seen experimentally, it is seen that Reynolds number tells you that if the liquid Reynolds number is 1000 and less, then whichever liquid whose Reynolds number is 1000 and less, it is a streamline flow. Understood? It's a
Yes.
streamlined flow. But something 2000 and more, it's called what? Turbulent. That means something less than 1000 is streamlined, 2000 greater than 2000 is turbulent. But what about the middle? It is a mix of streamline and turbulent. Is it clear? Clear?
Yes, sir.
Yes, sir.
It's a mixture. So if you want to see, maybe here it's streamlined, here it's turbulent. So Reynolds number 1000 is the minimum cap. Less than that, you get streamlined. 2000 and above, you get turbulent. Anything 1000 to 2000, you get mix of what? Both turbulent and streamlined. Is it clear?
Yes, sir.
Yes.
Yes.
So guys, can you please relog in?
Yes, sir.